Okay, guys. So how to draw a graph when you're given gradient intercept form. So first off, what does gradient intercept form look like in general? We've talked about it a couple of times. How would you generalize that? I've given you the example. You've not written it down. So y equals mx plus c. Okay? Got that? So you won't need your laptop just yet, I know.
Oh, I have them.
I know, but you don't need it just yet. So writing it down. Right, so I should expect the title. Alright, what we're doing. We've got the general form, and this is for a linear equation. Okay. What does m tell us? The gradient. Yeah. What's another name for gradient? Slope. Yeah. Another name? What does it represent? Yeah, got this down. The rate of change. Okay, so we've got three things there that m could represent. Okay, we've covered them all, right? Gradient, slope, rate. How do we find m, by the way? Sam? But I gave you kind of a little formula. It's not where it is on the y-axis, actually. You're thinking of the other one. It's like a little formula for it. Do you remember? 2 R's. Yeah, good. It's the rise divided by the run. It's how things change on the graph, yeah? How quickly the graph goes up. So we've got rise divided by the run. And like you said, when you see that on a graph, you kind of draw in your triangle, don't you? Yeah. Alright, so that's the m. So I know we've talked a lot about this, but maybe we haven't done enough notes. So we've got the m is the gradient, okay, in gradient and intercept. Right, so m is rise divided by run. Okay, what bit have we not mentioned then? The plus c bit. So we've got the plus c. And that will be the intercept. Right? So, what is the plus c? Yeah, but be specific. Sorry, my pen's not running. The y-axis intercept, and what does that mean to people that might not understand that? Not you guys, because you understand it, but if you had to give another way of explaining the y-axis intercept, what would you say? Where the line, good, where the line crosses the y-axis. Should we call it the vertical axis? Yeah? Where the line crosses the vertical axis. Okay. So the coordinates of that, so I can say the coordinates of the y-axis intercept will be, or does anyone know what the two coordinates will be? or one of them will definitely be a certain number. You can tell. What's the coordinates of a number where if it crosses the y-axis, what the coordinates at that point be?
0.
0, and then whatever c is, yeah? 0 and c, that's where that one might have confused you, alright? So 0 and c will be the coordinates. Alright? All of that makes sense so far? Written that down well? Want to move on? You've done that, Luke? Yeah? All good? Alright, so what we want to do, it's strange because, I can see the lines when I look this side, I can't when I see it this. Right, so what we're going to do, for the exercise in the book, it says, right, have you all finished writing? Right, the exercise says, graph the following linear relationships using gradient and y-intercept. So the idea is, well actually let's show you the difference. So it's because you've done this before. So if I said graph, right, draw the graph of y equals 2x plus 3. Alright, so don't do this yet, you don't need to write this down yet. Alright, what we've done in the past is to write down a table first, haven't we? So if I just do, you don't need to do this because I don't want you to do it again. So we would have x and y, and we would say x is 0 and 1 and 2 and 3, yeah? And then we would work out what y is. Who can tell me what the y would be when x is 0? How do we work it out?
0.
Like I said, don't write this bit down. Right? There's no need. So what would it be? 0 and... Do you all remember how to work it out? No one? No one in this room remembers how to work this out. All that work we did on it. What does this mean? What's times 2?
The x.
So the x number is times by 2, and then we add 3, and the result we call y. So let's do it. The x is 0, so what's 2? 2 times 0 plus 3 is? 3. So that goes there. Remember doing it now?
Yeah.
Alright, the next one is 2 times 1 plus 3, and then it's 2 times 2 plus 3, then it's 2 times 3 plus 3, then it's 2 times 4 plus 3. So what are the numbers? What goes with 1? What? 5? 7? 9? 11. You spot the pattern now as well?
Yep.
What's it going up by?
2.
And why is that important? Because the gradient is 2, and the numbers go up 2, because the gradient is how far it goes up every time, yeah? Or down. This one goes up. Do you also notice, actually I should do it the other way around. So the gradient, look, is 2, and that's because when it goes up plus 2. Alright, so that's the gradient bit. Alright. Do you also notice from what I said before that when x is 0, y is 3, and how does that relate here? Okay, we've got the plus 3 bit. Right? Now what we also then did is we turned these into coordinates. Remember doing this? So it was 0, 3, and then it was 1, 5, 2, 7, 3, 9, 4, 11, and do you remember plotting those points? Yeah? And drawing the graph. Now, what we're going to do is we're going to eliminate this whole stage. Right, that's the point of it today. So we don't have to plot that. Right? So how will that work? Well, it works like this. We're going to use the gradient and the intercept instead of doing all of this. Right? Does that make sense? Yeah. So I'm going to draw my graph, my axis. Oh, I always get a squiggle. I don't want it. Right, I'm going to draw my axes. All right. Sorry, my lines are a bit. I can't see them very clearly. All right. So what do I do to draw this line? Well, what axis is this one, by the way?
That's the y-axis.
That's the y-axis. So what's an important point on that line?
0, 2.
Not the 0, but the 3, isn't it? So I go up 1, 2, 3. Why is that important? Because that's the +3 bit, yeah? Yeah, got that? So that means that I can put my first mark there. What's the coordinates of that point? 0, 3, look, this one. Only I've not done it that way, I've just gone, well, it's 3, so it crosses at +3, because it's +3. What if it was subtract 3 afterwards? You put it below, you put it down at -3. Now I have done it properly this time. It's not a rough sketch. I have the squares marked, alright, although they're not the clearest thing. Right, so now I need to use the next thing, which is the gradient. So any ideas how I could do that? Sam's hand wants to go up. Go for it.
I'm trying to remember.
Yeah. So I'm going to bring.
You need 2 of the points.
Say again.
You need 2 of the points.
Well, yeah. Well, how do I get another point? So let's ignore this even exists. So tell you what I'll do. I can probably. No, it's not doing that. No. Should. So transparent. Should be covering it over, but it's not. All right. So let's ignore all this. How do I use the gradient being 2 to get another point? Well, what does gradient mean again? Slope. How do we work it out? Rise divided by run. Give me 2 numbers that divide to make 2. 6 and 3. Yeah. Any others?
4 and 8.
4 and
8.
well, it wouldn't be 4 and 8. It'd be 4 and 2. It could be 8 and
Oh, 8, yes.
8 for that way.
12 and 6.
12 and 6. 14 and 7. You get any idea? There's one that you've missed that's really simple. 2 and 1. So what does that mean, guys? Well, that means that the rise is going to be 2 and the run is going to be 1. So how about using that? So look, from this point, I know that if I go across, how far? 1. I have to go up 2. Up 2, and there's another point. Now, if I wanted to, I could use 4 and 2. So I go across 2 to 2 and go up 4, which would take me up to 7. Do you notice how these coordinates are here now then? 2, 7, 1, 5, they're all there. But I've just used the fact that the rise and the run, so the rise is 2, or the rise is 4, but the run is 1, so if it's 2 and 1, or it's 4 and it's up to you which one you want to do. But do you see how we've got some points?
Yeah.
And what can I do now? Put your ruler down and just draw the line, yeah? Trying to be as accurately on the lines as you can, yeah? Now it should be that every time you go across 1, you go up 2. So I can draw it without any need for all these coordinates, alright? So this one, the next one I'm going to do with you, we will write it down. Okay. So I'm going to ask you to graph y equals, I'm going to do a tough one, alright? Negative 3 over 2x plus 6. Alright? So, what I've got is, what's the gradient? Well, it's negative 3 over 2, yeah, but it's 3 over 2. What's the y-axis intercept?
6.
Positive 6. Yeah. Now, what does this mean, the negative 3 over 2? M is negative 3 over 2. So we've got rise over run equals negative 3 divided by 2. So actually this one's easier because it's already in that form, even though it looks harder. Do you want to write that down to start with? Go for it. What I'll then do is I'm going to draw a graph. Now I need to make sure that I've got room for my plus 6. So I'm going to draw a line that goes down, and then I'm going to do it a bit lower because I need room for my plus 6. So I'm going to have 1, 2, 3, 4, 5, and I'm going to have a 6 there. Why am I going to have that there? Luke?
Sorry?
Why am I going to have the 6 there?
Because you're doing it by 3.
Nope. I've gone up in ones. 1, 2, 3, 4, 5. But why have I put a special mark at 6?
Oh, because it's plus 6.
Because it's plus 6. Good. Alright. So that's the plus 6 bit. Alright. This is my y-axis intercept. Plus 6. Alright. How now do I use my rise being negative 3 and run being 2 from that point? Say again? I'm not going to do it. No, I actually don't. It does mean divide, but I don't want to divide. The reason why I don't want to is because it's already in rise and run form. Yeah? If I turned it into a decimal, it wouldn't be anymore. So actually just treat it like the rise is negative 3 and the run is 2. So the first thing we can do is use the fact that the run is 2. What does that mean? We do. So from the point I know at 6, exactly, you go across 2. Alright, so that's your run of 2. And then we go down. Good. How far do we go down? Good. 1, 2, 3. And that will be at 3, won't it? Because we go down 3. So my run, okay, of 2, which is that, and my rise is a negative rise, so I'm actually going down, okay? And my next point is here, and it's at, this point is 2 because I went across 2, yeah? And the blue one is at 0. Right.
It's 10
No.
it's 10:30.
Yeah, it's
A lot
not.
is going on.
It's just must be a test. Right guys, so now I've got 2 points. How many other points do I need?
1 minute.
I actually don't need any more points. Alright, but it might be nice just to do a few. Let's go across another 2 and go down 3. There's another point. Across 2 and down 3. Go this way. I go backwards 2. What direction do I do? Down 3. No, I'm going backwards. So if I go left 2, I have to go up 3, yeah? Because what will they all be in? a straight line. So here's some points, and there's my line. And you'll notice that the rise and the run is always 2, 3, back to the line, 2, 3, back to the line, 2, 3, back to the line, yeah? So there you go. There's my line. Y equals negative 3 over 2x plus 6. I'll let you draw it. Right, so question 1. Well, this one, look, actually, let me take a quick snipping so we can just talk about it. Of these.
Question 1 is probably the easiest one.
Oh yeah, which is nice because you wouldn't want question 2 to be easier than question 1. That would be. All right, just so you're all good, because a couple of them can be a bit tricky. All right. All right. What is the gradient and intercept for A, for instance? Because that one could be tricky. You might actually already know y equals x from that task we did last lesson and just draw it no problem. Alright, but I don't want to confuse you because it still could be mx plus c. So in this one, what is m? What? Not y, no, is this? It's what?
X.
Not x. Okay? Nope. 1, isn't it? M is 1. Why is it a 1? Yeah, there's a 1 there, but we just don't write the 1. What's the C? No. C is what you add on, yeah? So what do we add on here? 0, isn't it? There's nothing there. So the C is, so this one is like having 1x plus 0. So let's just have a quick look. So the gradient would be 1. What's the gradient in this one? Negative a half. Gradient on this one? 2. Gradient on this one? Negative 3. 2 over 3. It's actually negative 2 because it's next to the x, isn't it? This one? 5. This one? This one? It's the negative and the divide by 4. So for this one's a bit tricky. What did I tell you last time about another way to write this? Y equals negative 1 over 4x. So the gradient is actually 1 over 4. Alright, let's just check then. What's the y-intercept? Well, this one is plus 0 because there's nothing there. This one is negative 4. This one is good, plus a half. You're going to have to think about how you would draw that. This one is plus 7. This one is plus 1. This one is at the 3, isn't it? Yeah? Positive or negative? Positive, isn't it? There's no sign, it's a positive 3. This one? Negative 3. This one? Good, 0. Plus 0. This one? Good, plus 0 again, yeah? There's nothing there. Alright? So be very careful because they would have caught you out with this one especially. Now don't forget, when it's a fraction, the top number is the rise. The bottom number is the run. All the time, yeah? Rise, run. Where does the negative go? But which number? The rise or the run? Good. The rise. It's always on the rise, yeah? Negative 1. This one is negative 1. Right? Just like -3 is fine, -4 is fine, but when it's a negative with a fraction, the negative goes with the rise. Alright? So I think you should be able to get through quite a few of those. Sketches, draw the rest, yeah? All good? Go for it. Are you listening? Are you writing? I'm recording. Don't make me say your name and shame. Okay. Y equals 6x plus 2. Right. Start at 2. Yeah? Go up 6. Across 1. Note. Warning. Someone, and you can write not me, will do it the wrong way round. What do I mean by that? They'll start at 6 and go up 2. Why? Because it makes sense that the left number, the one you read first, is where you start. Alright? Now I say that because it's a common problem. When people, it's a very common problem. And I say it's a problem because I've already had 3 of you in the room having done it correctly twice, and then you do another one and suddenly you want to do it the other way around. Alright? So, I always like to talk about the possible mistakes. This is a big one. Alright? Doing it the wrong way round. This is what I go up by, because it's how many x's there are, yeah? If I've got 1 6 or 2 6s, if x is 1 or 2 or 3, I have more 6s, so it's going to go up, right? The +2 does nothing other than starts me at 2, yeah? So don't get it the wrong way round because you want to read it left to right. So make a big note in your book, warning, don't do that in your test. And if I do it in my test, Mr. Potts will say, you did it in your test even though I warned you about it. Alright?
You call out on me.
I will call you out on it. Alright, have a good one.
Take a shout out for that.